Hi class, now we are doing 17.3, Triangle Similarity. So again, the unit that we're doing involves proofs. So now we're going to learn how to prove that triangles are similar. Now if you recall, similar triangles are, I didn't want that color. Similar triangles are the same shape, different size. So if they're similar, then what we know already to be true is that all the angles are congruent. These are not very beautiful triangles, and they're not big enough for me to even mark, but the angles are all congruent, so they're marked that way, right? And the sides are not congruent, but they are proportional, meaning that if I take corresponding sides and divide them, I get the same ratio for all three sides. So that's the case for all similar triangles. Now again, we could just prove that's the case. We could take all three angles and show that all three angles are congruent to their corresponding angles. We could take all their side ratios and divide the smaller triangle corresponding side with the larger triangle corresponding side with all three side pairs and show that all the ratios have the same scale factor and they're equal. And therefore, yes, the triangles are similar. However, we like shortcut methods. We don't want to have to try to prove everything if we can just prove a few things and know for sure with those few things proven that the two triangles are indeed similar. So what we have are three shortcut methods that are very like, I want to say similar, but that's an overused word this time, very much like congruent triangles, but they're similar instead. They're proving the triangle similarity instead of triangle congruence. So some of them even have kind of the same name, like side, 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 but they have this little similar tilde sign that follows. So we say side, side, side similarity and side angle, side similarity. And then those are much like the congruent triangles, aren't they? Those little shortcut methods for proving triangles are congruent are very like that, very much like that, but a little bit different. And we have a brand new one, and that is angle-angle similarity. So those are the three shortcut methods that we're going to use to prove triangles are similar. So angle-angle similarity, we're going to start with. Angle-angle similarity means that with our two triangles, it says if I know two angles are congruent to each other, then I know the triangles have to be similar. And they do have to be similar without, you don't even have to prove that the sides are proportional. You know that with two congruent angles, you actually have three congruent angles, right? Because if this angle's 30, this angle's 30. So those are both 30. If this angle's 50, this angle's 50 because they're congruent. Two of the three angles are congruent. Now, if they add to 80, what's left? 100. It has to be 100 in both cases. So two angles being absolutely congruent guarantees a third congruent angle. And there's actually a theorem that proves that, but I just wanted you to see that. There's no reason to write AAA similarity because AA similarity means the same thing, and it's a little bit of a shortcut in and of itself. So a shortcut for a shortcut, and that's how mathematicians like it. So it says that if two corresponding angles are congruent, then the triangles are similar. All right, and then you know for sure they're congruent. So our examples here determine if the example below are similar by angle-angle similarity, and if so, write a similarity statement. Now, of course, they're not going to make it way easy. They're going to give you two angles, but do you know if they're the same corresponding angles? We don't know that, do we? All right, so we're going to check it out. So example 1, you have an angle that's 74 and an angle that's 75 in the first triangle ABC. And the next one, the smaller of the two, we have a 75 and a 31 degree angle. Now, at first look, you say, oh, well, I have one, 75 and 75, so that's good, but I don't have a second one, so you might just move on. But they're trying to trick you, so don't be fooled too easily. Figure out what the third angle is, because you don't know if you have corresponding, those are the corresponding angles, and therefore supposedly congruent, but not, so therefore not similar. So you have to figure out what the third angle is. This one might just be 31, like the other angle and the other triangle is. You just don't know it because they didn't tell you. So let's figure out what it is. So we're going to take 74 and add 75. And we get 149, and then take 180 and subtract 149, and voila, It is. That is our 31-degree angle. They just tricked you because they didn't give you the same angle. They gave you different angles for the second angle. So that one's 31. This one's 74. And because, yes, indeed, I have two congruent angles, then these are similar by angle similarity. All right. So don't be fooled. All right, example 2. We have an angle right here that's congruent, marked by a single arc, and so we know those are congruent. We have nothing else, and initially you might say, oh, I need 2 angles, I have 1. Then you think to yourself, oh, ho, ho, here I have vertical angles, those are congruent, so voila, I have angle similarity. So be careful with things that aren't marked. Don't forget that vertical angles or anything that's unmarked that we've learned before, but still true. We could have congruent angles. All right, side similarity. Side similarity says that if I have my 2 similar triangles, and I know that my sides are proportional, that means I have 3/6 equals 5/10 equals 4/8, which in all 3 cases it does. I have a half, and a half. So yes, indeed, the sides are proportional. All the ratios are the same. Then the triangles must be similar. We don't even have to check for congruent angles. We know for sure the angles will be congruent because the triangles are similar by side similarity. So for example 1, oh, did I just do that same? You know what? I didn't even look at that. I just did the same triangle. Sorry. Oh, well, I don't know. 3, 4, 5, and 6, 8, 10. Anyway, we take this smaller of the sides. Now, if I don't have a similarity statement, I don't know which angles are congruent to which angles. So I don't know which sides are corresponding to which sides. But I'm guaranteed that I can find 3/6. Those 2 are the smallest of the 3 sides. 3 is smaller than 4 and 5. 6 is smaller than 8 or 10. So I know the smallest sides are corresponding sides, the medium sides are corresponding sides, and the largest sides are corresponding sides. So we're going to set up our ratios using side length. Small to small, medium to medium, which next would be 4 to 8, and large to large, which would be 5 to 10. So indeed, that's 1/2, 1/2, and 1/2. All ratios are equal to 1/2. That's also the scale factor. And yep, those 2 triangles are similar by side similarity. Okay, not too bad. Next one, let's check the next ones out. Again, we don't have a similarity statement to go by, so we're just going to take what I like to do when I don't have one, just to make sure I do everything right. I just take my 3 sides, put them in order, 30, 32, then 35, smallest to large from one triangle, and then I put them over smallest to large of the other triangle, which is 24, 25, 30, right? Or 28, sorry, 28. And I just do it that way, and then I don't have to worry about side to side, and I've got them lined up. So small to small, medium to medium, large to large. And then I'm going to just put that in my little calculator. So 30 divide 24, hit enter, I'm not even going to look. 32 divide 25, not even going to look. 35 divide 28. Now I'm going to look. And what I have is I have 1.25, 1.28, and 1.25. Those are definitely not equal. Not equal. So nope, they are not similar at all. Otherwise, if they were, I would have had 1.25 straight across as my ratios, but I don't. I have 1.28 that snuck in there, made my triangles not similar. All right. Okay, next one, side angle side similarity. Ooh, this one's a little tricky one because again we have that angle right there. That's the included angle because included angles have to be between the 2 sides that have the same proportion. Side angle side similarity means that this side and this side that are corresponding sides have the same ratio as this side to this side. So if they have the same ratio, and then the angle between them is congruent, then the triangles are similar by side angle side similarity. It says if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. All right, so what we have to make sure that we have in the very beginning, I'm going to erase that little mark that's sweet. All right. I needed to make sure that you understand what that included angle means. That means I have a side that's proportional to a side, okay, and I have the measures for both. I do have 8 and 6. And a side that's proportional to the other side. That means when I divide the two sides, in both cases, I get the same exact ratio. And then the angle, that A is the angle between them, is congruent to each other. And in this case, I have the angle and I know the sides, but I'm not guaranteed that they're proportional yet unless I check them. So I take the smaller over the smaller, 8 over 6, and set that equal to the smaller 20, or the greater 20 over the greater 15. Okay? So I have to check that first. I've already checked the angles. Yep, the angles are congruent. Check. But I need to find out that the sides are proportional. So 8 divide 6 and 20 divide 15. And I get 1.3 with the bar above it equal to 1.3 with the bar above it. And indeed, they do check out. So the sides are proportional, the angles are congruent. Therefore, you would say, yep, by side angle side similarity. Remember that little similarity symbol because that's the way that distinguishes side angle side with the congruent triangles theorems from the similar triangles theorems. Okay, example 6. Now, with this one, you have to be a little careful because this is one triangle and it's overlapping. Here's my angle. And then if I put a different color, that might help you understand. We'll do this, kind of highlight. This is the bigger triangle and it has the same angle. Okay, so without too much worry, we need to make sure that we do side to side. Those are the corresponding sides. One's 15 and one's 25. So 15 over 25 is the ratio of sides that are the corresponding sides on AD and AB. Now, over here, we have a side that's 12 and a side that's 21. So 12 over 21, remember we're doing small to big, so this is our first, this is our second triangle. So 15 over 25 has to equal 12 over 21. All right, and we do have the included angle. It's the same exact angle. It's a reflexive angle, but therefore still congruent. So our angles are a check. Our included angle is a check, but 15 divide 25 and 12 divide 21, we need to have equal. This is 0.6, and this is 0.57. Not congruent, so nope. Not similar, and it's just because my sides were not proportional, were they? All right, that's the lesson. Get on with 7-3. Hope you have a great time. Oh, and they're just all little checks, and if you have any questions, let me know. In fact, I kind of have a minute here. Let me see if we can do one problem. Oh, I only have 1 minute, so I'll have to be quick. Determine whether these are similar. So I have a side, an angle, and a side. So we're going to check proportionality for the sides. 3 is smaller and 9 is smaller. 5 is larger and 15 is larger. That is 1/3 equal 1/3. So the sides are proportional. I have my angle that's congruent. So I would say, yep, by side angle side similarity. All right. Okay, good luck with this. Have a great time and finish up the homework.